Hello, my dear students. I welcome you all to class 11 mathematics, and the topic for the day is the very first chapter of your class 11 mathematics, that is set theory. Now, before we begin this particular concept, I want to tell you that this is the very base of your higher mathematics. So, whatever we are learning, give your heart and soul, practice the sums, and learn and enjoy. Okay, so let's begin with the first topic, that is definition. Okay, so let's try to understand the definition very carefully. So we see that any well-defined collection of objects is called a set. Now the very word set means a collection, right? It's a group. So now what kind of group we are talking about? It is a well-defined collection of objects. Now what is the meaning of well-defined? Let's try to understand. Okay, so well-defined collection means in that particular collection, certain object cannot repeat. Okay, so that means every object of that collection has to be different. Okay, so none of them have to be same. So that is one of the meaning of well defined. Okay, and well defined means whatever collection you are making, that collection has to be same for everyone. Okay, so for one person the collection is different, and for other person the collection is different. Thus that kind of collection will not be called a set. Okay, so let's see some examples in order to understand this definition. Okay, and the objects of the set are also called elements. You need to remember this. Okay, so state which of the following given collection of objects is a set. So I have written some collection out here. Okay, so let's see whether these 11 collections are well defined collection or not. If they are well defined, then it is considered to be a set. Okay, so we have a collection of popular cinema actors of India. For example, if I ask you to form a collection of your favorite or popular cinema actors of India, you will form some collection. Okay, and if you ask me the same, I'll also form some collection. But your collection might be different from mine, isn't it? So that's why such kind of collection will not be well defined. As I said, collection has to be same for everyone. So that's why number 1 is not a set. Okay, number 2, the collection of even natural numbers less than 51. Now if I ask you what are the even natural numbers less than 51, you will start with 2 and end up with 50, isn't it? So from 2 to 50, how many ever number comes, they are even natural numbers which are less than 51. So for you also that collection is same, and for me also that collection is same. So such kind of collection is called well defined collection. Okay, so that's why this becomes your set. Okay, similarly we have the collection of counting numbers less than 1. Okay, so if I ask you what are the counting number less than 1, then you have 0. Okay, so you say 0 is the only counting number, and for me also 0 is the only counting number. Okay, so that's why this is also your set. Fine. So we have similarly collection of interesting books written by Shakespeare. So you see Shakespeare has written many books, right? So out of those books you may find only few interesting, and whatever you are finding interesting, that might not be interesting for me, isn't it? So that's why number 4 says that this is not a well defined collection. That means this is not a set. All right, so similarly you can check the remaining ones. All right, so I hope the thing is clear to you. Very good. Now let's move on to the next topic. Now the very important thing that you need to remember is a set is denoted by a capital letter. Okay, and the objects of a set are denoted by small letters. All right, now we need to learn some standard notations. Okay, so this n written in this special manner is called as the set. As I said, set is represented by a capital letter and this is also a capital letter. Okay, so whenever you see this, this means this is the set of all natural numbers. That means the numbers 1, 2, 3, 4, 5, 6. So if I keep all of them in a group or in a collection, then that collection is called your set of natural numbers and it is denoted by n. Z stands for set of integers. Okay, so a set of integers means 0 plus minus 1 plus minus 2 plus minus 3 and it continues. Okay, rational number. So Q stands for set of rational number and they are the numbers of the form a by b, where b is not equals to 0. Remember that. Okay, next is R, set of real numbers. Z plus is the set of all positive integers. Similarly, if you get Z minus, this means the set of all negative integers. Similarly, you have Q plus, set of all positive rational number. R plus is set of all positive real numbers. And W stands for set of all whole numbers. Now, before going into the next slide, let me tell you that sometimes you may see I also. Alright, so I also stands for the set of all integers. Okay, so pause the video and note down the notations. Now let's learn about the representation of sets. So basically sets are represented in two ways. Okay, so let's start with the first way, and the name of the first way is roster form, roster notation, or we call it tabular form as well. Okay, so tabular means in a table. In table you note down all the data, isn't it? So basically when you represent a set in a roster form, you have to mention each and every element. Okay, and those elements are represented within a curly bracket, or we call it braces as well. Okay, so in this form we enumerate or list all the elements. Okay, for example, as I said, capital letters denote a set, isn't it? So first is capital A is a set of whole numbers less than 6. Now what are the whole numbers which are less than 6? The whole numbers which are less than 6 are 0, 1, 2, 3, 4 and 5. Yes, so if I keep these numbers in a curly bracket, then this becomes my roster form or tabular form, where I have enumerate all the elements. Okay, now one thing that you need to remember is here order doesn't matter. If you want to write this as 5, 4, 3, 2, 1, 0, that's also fine. Or if you want to write 1, 2, 0, 3, 5, 4, that's also fine. So order doesn't matter, but the only thing is any element should not repeat. For example, 0 is written only once, 1 is also written only once. Similarly, all other elements are written only once. Okay, so that's what is the property of a set. Okay, next. Now, capital C is the set of letters in the word excellent. Okay, so let us see what are the letters. So the letters are E, X, C, E, L, L, E, and T. Okay, so we have the set will be written in E. So the first letter is written. Next is X. Okay, next is C. C is also written. Again E is there, but E is already written. So that's why I should not repeat the element, right? Okay, so next is L. So L is written. Again we have got L, but L is already written. We should not repeat it. We have E. E is already written. We have N and we have T. Okay, so we have got these many letters in this particular set. Okay, so this is the representation of a set in tabular or roster form. Okay, so next is called set builder form, and this is also called rule method. Okay, so here what happens is we specify the rule or property or statement. Now what's the meaning of this? We will try to understand using some examples. Okay, so there's a set capital A, and within this we have to mention one variable, and most often we write the variable as x. Okay, this means such that, so we read this as A is the set of elements x. Okay, element is x and x has some property. Okay, so what is that property? We'll learn using the examples. Okay, and this is called such that. So this is read as A is a set of elements x such that x has a property p. What's the meaning of this? Let's try to understand using examples. So let me take the first example. Now A is given to be 2, 4, 6, 8, 10, 12. Now whenever you are writing any set in set builder form, you always need to look for some pattern. For example, if I ask you what kind of pattern you can see out here, you see that these numbers are even numbers less than or equal to 12. Yes, or you can say even numbers less than 14, isn't it? So that's how you see some pattern out here. Okay, so as it is said, in set A, all the elements are even natural numbers up to 12. Okay, so that's why this in roster form can be written as, set builder form can be written as A is a set of elements x such that x is what? The elements should within A should be what? They has to be even number, right? So that's why x is an even number and even natural number, right? And this has to be less than or equal to 12. All right, have you understood this? Okay, so let's see one more example. So here what is given? B is a number, B is a set with numbers 4, 5, 6 and 7. So only 4 numbers are there, and if you see here we have all the elements are natural number, isn't it? And these are the natural numbers between 3 and 8, isn't it? So that's why this can be written in set builder form as B is a set of element x such that x is a natural number. This means x belongs to n, and this means x is a natural number, and x is lying in between 3 and 8. That means 3 is less than x, the element, and this number has to be less than 8. Alright, so that's what is the meaning of this. Alright, fine. So let's take some problem. Now use roster method or tabular form to represent the following sets. Okay, so we have the number, counting number, which are multiples of 6 less than 50. So the counting numbers which are multiples of 6 means you have to remember the table of 6. Okay, so let us list down, or let us write the set or the collection which contains multiples of 6 which are less than 50. So these are the multiples of 6, isn't it? 6 1s are 6, 6 2s are 12, 3s are 18, 4s are 24, 5s are 30, 36, 42 and 48. Yes, okay, so these are the only numbers, counting numbers, which are less than 50 and are multiple of 6. Okay, so this is one of the collection, in fact only one collection which satisfies this. So this is the roster form. Now let's write the fraction whose numerator is 1 and whose denominator is a counting number less than 10. So numerator always has to be 1, remember that. Okay, so my answer has to be 1 by denominator. The first counting number is 1. Okay, so 1 by 1 is how much? 1. Next is 1 by 2, 1 by 3. Denominator are counting number less than how much? Less than 10. That means we have to terminate with 9. Okay, so these are the only counting numbers. Okay, so please remember in one of the example I had said that the counting number is 0. We don't use 0 for counting. Okay, so we count using a number 1 2 3 4 5 6 7 8 9, and it continues in that way. All right, next is number 3, which says x. Okay, x is what? X is a natural number and x is a prime factor of 84. So basically this is a set containing prime factors of 84. Okay, and the prime factors, if you factorize 84, out of the factors, all the factors, you will see that only 3, 2 and 7 will be prime numbers. All right, so that's why the prime factors of 84 are 2, 3 and 7. Okay, fine. Now we have number 4, set of odd integers lying between -4 and 8. Okay, so take a number line, and from number line pick up the odd integers lying in between -4 and 8. So the odd integers will be -3, -1, 1, 3, 5 and 7. Okay, set of all natural numbers x. Now you are writing set of numbers x. Okay, for which x plus 6 is less than 10. Now x is what? X is a natural number. And what is the first natural number? First natural number is 1. Okay, so if I put x equals to 1, then what is this? 1 plus 6. And 1 plus 6 is 7. And is 7 less than 10? Yes. So that's why in my set, I can put number 1. Now let us put x equals to 2. Now if x is equals to 2, then this becomes 2 plus 6, which is 8. Again, it is less than 10. So that's why in my set, I can include 2 as well. Similarly, you can put 3. Yes, because 3 plus 6 is 9, which is again less than 10. Now, can we choose 4? That's the question. Now, 4 plus 6 is 10. And we know that 10 is not less than 10. 10 is equal to 10. So that's why I cannot put 4. Similarly, if I put 5, then 5 plus 6 gives me 11, which is more than 10, isn't it? So that's why in my set, I should have only 3 elements, 1, 2 and 3. Okay. Similarly, we have set of all integers x. Now this time x is an integer for which x plus 6 is greater than 10. Okay. So basically, if my total has to be greater than 10, the number will be 11 and the value for x has to be 5. Okay, and 5 plus 6 is greater than 10. Similarly, greater than 5 is 6, right? So 6 plus 6 is 12, again greater than 10. So basically, if you take any number which is greater than 5, greater than or equal to 5, then my x plus 6 has to be greater than 10. So that's why my number will be 5, 6, 7 and it continues that way. Okay, so dot 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 means it is continuous. Fine. Now we have the next, that is set of all integers x for which x plus 6 is less than 10. So obviously these will be the number. Okay, so last number is 3, right? So from 3, if you go down, we have 2, 1, 0, -1 and it continues, right? So the biggest number is 3 here and 3 plus 6 is 9, which is less than 10. Similarly, you have 2 plus 6 is 8, less than 10. So you go beyond this 3, okay, you will have all the numbers whose sum with 6 is going to be less than 10. So these forms the required set. Number 8 says the set of all integers x for which 60 by x is a natural number. That means x has to be a divisor of 60. That's what is the meaning of this. Because 60 divided by x is a natural number, means when you divide 60 by x, you are getting a natural number, which means x is a divisor of 60. And what are the divisor of 60? The divisor of 60 are these numbers, isn't it? So this gives me the required set. Now x is an integer, I is integer, remember that, which is lying in between -half and 9/2. If you draw a number line, plot -half, which is in between 0 and -1, plot 9/2, which is 4.5, which lies in between 3 and 4. 4 and 5, isn't it? So the number in between, integers in between -half and 4.5 are these numbers. You will come to know about this from number line. Next is this set. Okay, so we have to write this in roster form. So what is this? X is a natural number. So what is the first natural number? First natural number is 1. So if I put the value of x to be 1, we have 4 into 1 is 4 minus 3. So 4 minus 3 is how much? It is 1. And is 1 less than or equal to 15? Yes. So that's why in this set I can put x equals to 1. So basically we have, when x is equals to 2, then this becomes 4 into x, that is 4 into 2 is 8, 8 minus 3 is 5. Again it is less than or equals to 15, so that's why I am including 2. Similarly put 3. Okay, so we see that when you put 2, 3, 4, this condition is satisfied. That means this number becomes your less than or equal to 15. Now let's go to 5. If x is 5, then 4 into 5 is 20, minus 3 is 17, and 17 is greater than 15. So this condition is not satisfied. So that's why I have not put 5 in this set. Okay, so in this question you have to put such numbers, such natural numbers in fact, whose square is going to be less than 40. So obviously these are the numbers. Now 6 square is 36, less than 40. Next is 7. 7 square is 49, right? So this condition is not satisfied. So that's why these are the only numbers. Okay, similarly for this, my numbers will be this much. Okay, so x is an integer, remember. Okay, so minus 3 square is 9, less than 16. Minus 2 square is how much? Minus 2 square is 4, less than 16. Minus 1 square is 1, less than 16. 0 square is 16. 0 square is less than 16, right? Similarly, we have these numbers also satisfying this. So that's why these are the required numbers. Set of all digits in our decimal system. So in our decimal system, we have got the numbers 0, 1, 2, 3 till 9. Okay, fine. Next is the set of all letters in the word trigonometry. Okay, so we have already seen such kind of example. So we have in only these letters. All right, so the letters, for example, O cannot be written twice, right? So only once it is written. Set of all vowels in English alphabet which precede Q. That means the set of all alphabet which comes in front of Q. Okay, vowels which comes in front of or before Q. So these are the only alphabet English alphabet vowels which precede Q. Okay, similarly we have X is a consonant in the English alphabet which precedes K. Okay, so these are the letters, consonants which precedes K. All right, so you may pause the video and note it down. Now let's take another question. So question says, write the following sets in set builder form. Okay, so in such questions, again, as I said earlier, you have to look for some pattern. Okay, so what kind of pattern do you see here? We see that all are odd numbers in between 1 and 13. So that's why this in set builder form can be written as set with element x such that x is an odd natural number less than 14. All right, next is all are even number, so x is an even natural number. Okay, we have next, so all these are, if you see here, multiples of what? Multiples of 3, isn't it? But till where? Till 5. So that's why it is written x is equals to 3n multiple of 3, where n has to be a number less than or equals to 5. Okay, fine. Next, if you see here, we have 2, this is 2 square, this is 2 cube, this is 2 to the power 4, 2 to the power 5, this is 2 to the power 6. So this can be written as x equals to 2 to the power n, where the power has to be less than or equals to 6. All right, next is this is 5, this is 5 square, this is 5 to the power 1 by 3, I'm sorry, 5 cube, this is 5 to the power 4, right? So that's why this is, the power is till 4, so that's why n is less than or equals to 4. Similarly, you have this is 1 square, this is 2 square, this is 3 square, this is 4 square, this is 10 square. So basically we have n square form where n is till 10. Okay, because final is 10 square, so that's why the biggest number has to be 10 here. Okay, similarly we have this is in the same format, but we don't have any restriction here. It continues, right? So that's why it is written x equals to n square, where n is a natural number. No restriction with the bound, upper bound. Okay, we have this is 1 by 2, 2 by 3, 3 by 4, 4 by 5. So basically if you see here, denominator is 1 more than the numerator. So that's why it is written as x equals to n by n plus 1. Denominator is 1 more. Okay, and what is n? N is a natural number. The starting number is 1, 1, 2, 3, 4. So that's why n is a natural number here. Okay, fine. Now there's a very important part you need to understand, and that part will be explained by this. If A is given to be this set, then write which of the following statements are true. Okay, so if a statement is not true, mention why. Now 3 belongs to A. This means 3 belongs to A. That means 3 is a member of A. Okay, isn't it? See, we have got 3. That's why number 1 is true. 5 and 9 are members of A, isn't it? So number 2 is also true. 8 does not belong to A. This is also true because we don't have 8 in this, isn't it? 9 does not belong to A. This is false because 9 is present, isn't it? Now this is wrong. Remember, okay? So you have set. Okay, so this bracket means set, and this set contains only 3. Yes, and do we have a set containing 3? We have a number containing 3. Okay, we have a number with 3, but we don't have any set within this, isn't it? So that's why this is false. Remember that 3 is present in this set, but set containing 3, that means set with number 3, is not present here. Okay, so this is false. Similarly, this is also a set, and we do not have sets inside this, isn't it? All these are numbers. So A does not contain any set. A contains only the numbers. So that's why number 6 is also false. Okay, most of the students are confused with this kind of problems which you may face in your competitive exams. Okay, so you have to understand this very, very carefully. Okay, so today we'll discuss a few types of sets. We'll continue the types of sets in the next class also. Okay, so today we'll take up the first one, that is called empty set. A set containing no element is called empty set. It is also called null set or void set. So that means you'll just write a curly bracket, and within that bracket there is no element. Okay, and such kind of sets are known as empty set, and it is denoted by this letter. We call it letter phi. Okay, so phi means empty set. Now let's take some example. Question says, which of the following are examples of the null set? Okay, so set of even prime numbers. Now do we have even prime number? Yes, we have. The only even prime number is number 2. So that's why we have at least one collection, isn't it? So that's why this is not empty. Remember. Next is set of odd natural numbers divisible by 2. Now do we have any odd natural number divisible by 2? No, right? So that's why number 2 is empty set. Okay, number 3 says set of Indian kids 5 meters tall. Obviously this is not possible, isn't it? So that's why this is also false, or this is also empty. Okay, so next is a set containing element x such that x has to be less than 5 and greater than 8. Can this happen together? No, right? X can, see, at one time x cannot be less than 5 and greater than 8. So that's why this is also empty set. Remember that. X is a point common to any two parallel lines. Or in other words, I can say that x is a point of intersection of two parallel lines. Is this possible? No, right? So this is also empty. So we have the last one, which says x is a student of your school presently studying in both classes 11 and 12. So there is no student in this world who is studying in two classes together. Okay, so this is also empty set. Hope the concept is clear to you. Okay, so if there is no element within the set, this is called empty set. Now, if the set contains only one element, for example, this first one, set of even prime number, it contains only number 2, isn't it? So, if there is only a single element, then such kind of set is known as singleton set. Okay. Now, next is finite set. Now, finite means something which you are able to count. Yes. So, a set consisting of definite number of elements is called a finite set. Okay. Now, if you are able to count the number of elements, okay, then the number of elements present in that set is called its cardinal number, and it's also called order of the set, and it is denoted by n of a. If there is a set A, then the number of elements present in it is known as, or it is denoted by n of a. All right. Now let's do this problem. So question says, classify the following sets into finite and infinite set. In case of finite set, mention the cardinal number. Okay. So all these are given in which form? All these are given in set builder form. So you have to write this first in your tabular or roster form if possible. For example, this number A is a set of integers less than 5. So what are the integers less than 5? It is 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, and it continues, right? Till where it continues, we don't know. So that's why the first one is infinite set. We are not able to count how many elements are there. Number 2 says, x is a whole number which is divisible by 4 and 9. Now, do you know how many whole numbers are there which is divisible by 4 and 9? You don't know, right? There are many whole numbers. So that's why this is also infinite. Now, next is x is an even prime number greater than 2. So is there any even number greater than even prime number greater than 2? No, right? Only even prime number is 2, and other than that is all are odd, isn't it? So that's why basically this is what kind of set? This is empty set, isn't it? And empty set means you are able to count how many elements are there. How many elements are there? 0 elements are there. You are able to count. So that's why this is finite set, and this is a null set. So that's why how many elements are there? You have to mention, if it is finite, you need to mention its cardinal number also. So cardinal number is 0 for this. Next is x is this set. X is a natural number and it is a factor of 84. And the factors of 84 are these. Yes. So you are able to count how many elements are there? There are 12. So that's why it is finite. Now, next is B is a set with element x, and x is what? X is a 2-digit number, sum of whose digit is 12. Obviously, this has to be finite because these are the numbers. These are the numbers, 2-digit number whose sum of the digits gives me 12. For example, 3 plus 9 is 12, 4 plus 8 is 12, 5 plus 7 is 12, 6 plus 6 is 12. Yes, so these are the only 2-digit numbers whose sum of the digits gives me 12, right? And how many digits are there? There are 7. How many numbers are there? There are 7. So that's why cardinality or cardinal number is 7 for this particular set. Okay. Next, this will also be finite because if I convert this into set, then this becomes my tabular form which contains 6 elements. So that's why this is also finite. Similarly, x here, x is equals to 5n. That means multiple of 5. X is a number which is a multiple of 5 where n is a natural number. Okay, so the first natural number is 1. So n is 1 means x is 5. When n is 2, then x is 10. Yes, so when n is 3, x is 15. When n is 4, then x is 20, but x has to be less than 20. So there are 3 elements out here. Okay, so the value of n here will be 1, 2 and 3. Okay, and the value of x here will be not 1, 2 and 3. The value of x will be 5, 10 and 15. Okay, instead of 1, 2, 3, you have to write 5, 2 and 15. So how many elements are there? There are 3 elements. Again, the cardinality here has to be 3. All right, so there is a mistake from my part while typing. So this has to be 5, 10, 15, and this cardinality becomes your 3. All right, very good. So we have next is this one. Okay, so obviously here in this case, since n is an integer, okay, so that's why this becomes infinite. Okay, so this becomes infinite set. How you can check? For example, if I choose n to be 3, this becomes 15. N to be 4, then this becomes 20. So basically we have to look for the integers which are less than 4. And how many integers are there less than 4? There are infinite number of integers, isn't it? Because we go to the negative side as well. So that's why this becomes infinite. Next is this one. So this will be finite. Okay, if this is finite, what will be the set? You will write by yourself. And what will be the cardinality? You will write by yourself. And I'm not going to talk about this. You verify by yourself. Okay, so pause the video and note it down. Thank you very much.